Okay, let's try and go over these problems that we had for homework the other night. So most of you got parts of it, and not everybody got to the end, so let's just see what we've been asked at each one. All right, this one is saying that if I'm looking here at the student who's pulling this up the ramp, that the parallel component that he is pulling with is equal to 30 newtons. So just this part that is actually the part applying up the ramp. Remember, the other piece is his pulling up a little bit, which is going to subtract from the normal force. But what it's telling us is, well, if I know that the part he's pulling with is 30 newtons up the ramp parallel, then what is the actual force he's pulling with, right? Because he's actually pulling harder than that. Okay, so since this adjacent piece is adjacent, adjacent is always cosine. So it's the x piece up that ramp. So what I'm going to say is f x up the ramp, right, is equal to f cosine of theta. In this case, that's 25. So I know that that part pulling up the ramp is 30. I want to know what f is. I know the angle of his pull is 25 degrees. So if I divide both sides by cosine of 25, then the amount that he is pulling with, FA, is equal to 33.1 newtons. That's this F here. Remember, the only part that actually is moving it up the ramp is this 30 newton component. Okay, so F is equal to 33.1 newtons for part 1. Now it says, how big would the component perpendicular to the ramp be? So I know that he's pulling with a force of 33, and now I want to know, what is this Fy? What is that part of the pull up off the ramp a little bit? So that's the sine component. It's opposite the angle. So Fy is equal to F sine theta. In this case, I know F because I just solved for it above. That's 33.1, and I know the angle of the ramp is 25 degrees. So 33.1 sine 25 means that my y component is 13.989 or something, so let's just call it 14 newtons, okay? So now, how big would the normal force applied by the ramp be if the sled had a mass of 5 kilograms? So let's do this in the two parts. Let's start by just looking at the 5 kilogram box. I know that the weight of a 5 kilogram box is just going to equal mg. So that's 5 times 9.8, or 49 newtons. And it's not horizontal, so I know that it's only part, right? This perpendicular part. Weight perpendicular will equal my normal. The weight parallel is actually going to be pulling it down the ramp, right? So if I draw those components, remember, on a free body diagram, never draw the components, but they are super helpful when you're calculating. So that weight perpendicular, remember, oops, I don't want to erase that. Why'd that go away? Okay. This angle and this angle are the same. So that the perpendicular component, the normal part, is now actually is adjacent. So adjacent, again, is the cosine. So weight perpendicular is going to equal weight. Perpendicular is equal to the weight times the cosine of the angle. So I know that my weight is 49. I know the angle of the ramp is 15. So 49 cosine is 47.3 newtons. Now, that would be the perpendicular if that were just sitting there, or if he were pulling on it horizontally, but he's not. He's pulling here up at an angle, which, remember, he's going to be pulling up off of the ramp a little bit. So the normal force is actually going to be a little less, right? It's going to be 47.3 newtons minus that little bit that he was pulling up off the ramp, which we just got above. So the actual normal force provided by the ramp is going to be 47.3 minus 14 newtons, and that's going to equal 33.34 newtons. Okay, so now we're finally wanting to know, okay, so what is mu of this ramp? What's the coefficient of friction? So really we're going to have to just add all of our forces together. So let's draw, not really a free body diagram, but kind of all the forces acting on this box. I say not really a free body diagram because we're drawing some components of forces on here as well. So he's pulling up the ramp, but only that X piece matters, going up the ramp, right? And then we've got friction that's going to work against that. And then we also have that the mass of that block, the weight of it, is also going to be kind of dragging it down the ramp, right? It wants to fall down the ramp because of the weight. So he is pulling one way, and friction and the weight parallel are working the other way. So I'm going to call the positive direction Fx. So let's add all of these together. So I have the sum of my forces is equal to ma. So let's add those three forces that we've got going in the direction of acceleration. So I've got my Fx, I've got minus Ff because I'm adding a negative because it's the opposite direction, minus weight parallel is equal to ma. Let's put some things in. So if I go back up to the top, part A, I see that I was given that x component of 30 newtons up the ramp. Ff is equal to mu Fn. I'm going to go ahead and put 33.34 in for, oops, 33.
Juniors, Justin is in the Learning Commons to share information about purchasing a class ring for Junior Week. Juniors, Justin is here in the Learning Commons to share
and the mass is 5.
Purchasing a class ring for Junior Week.
The acceleration is 3. All right, so I can now solve for mu. Oh, wait, I forgot weight parallel, guys. Whoops, sorry, that announcement messed me up. And this is the third time I've started this video, so we're gonna just keep going. All right, so we have Fx minus Ff. Now we need to subtract weight parallel. So weight parallel is just this piece going down the ramp. The piece going down the ramp, remember, is the sine. When I look at this here, it's opposite, so it's the sine. So it's going to equal weight sine theta. So let's just write 49 times the sine of the ramp angle is equal to m, which was 5, times a, which was 3, given in the problem. All right. Write that out, 39, or 30 minus mu times 33.34 minus 12.7 is equal to 15. So now I'm just going to do 30 minus 12.7 and subtract that from 15 on the other side. And I get mu, let's see, I have it in my calculator here somewhere. Okay, so I'm going to have minus 33.34 is equal to minus 2.3. Again, that's just 30 minus 12.7, and then take that and subtract it from the other side. These are both minus, so we can just make them both positive, right? And divide by 33.34, divide by 33.34, and I get my mu is equal to 0.067 or so. Oh, no, 68. 0.07 when I round up, and we're just going to leave it at that. So really smooth, it's no, that's good. I wanted a smooth one. Remember, this mu should always be between 0 and 1. That should give you some idea of whether you're right or not in your calculations. And I hope that is helpful.